So today we are going to work on geometric proofs some more, and then I'm also going to introduce flowchart proofs as well. So this first proof that we have right here, we are given that NL is equal to NM. So what I would do is just go ahead on your picture and draw that they are equal to each other. So if we have that these two segments are equal, so maybe something like that. I don't really know, just to show that they're equal to each other. And then AL is equal to BM. So I'm just going to put a line there. Those two segments are equal to each other as well. We're proving that NA, so we are proving that this segment, NA, is equal to NB. Okay, so those two segments right there are equal to each other. So my first step right here when going through this is looking at my first statement. So NL is equal to NM, AL is equal to BM. That is our given statement. And then we jump down to NL. We jump down to NL is equal to NA plus AL. So looking at our picture, NL is this whole entire segment. I can even show that. Okay, so if you look here, NL is this whole entire segment, and we are saying that is equal to NA plus AL. Okay, well, that is going to be the segment addition postulate. We're saying that one small segment plus the next small segment is going to equal the whole thing. So that is the segment addition postulate. Okay, and then we have NM is equal to NB plus BM. Well, NM is this whole segment right here, and we are breaking that up into NB plus BM. So again, that is the segment addition postulate. And then all of a sudden, we jump down to setting our two equations equal to each other. So NA plus AL is right up here. And then NB plus BM is right here. How can we do that? So let's think about this. If I have NL is equal to NA plus AL, and NM is equal to NB plus BM, well, our given says that these are equal. We know that NL is equal to NM. So this is going to be the transitive property. These are overlapping. These are our middlemans. Okay, they're both set equal to something that's equal. So then I can set our equations equal to each other. So then I know that NA plus AL is equal to NB plus BM. So again, this is going to be our transitive property. Okay, then I look from 4 to 5. It all looks the same, until we get right here. Okay, so BM became AL, and looking in my given, we were given that those are equal to each other. So that is going to be substitution. And then now that I have AL on both sides, okay, I could subtract AL from both sides, and I am just left with AN and NB. So that is going to be the subtraction property of equality there. And then we are finished. Moving on to the back, we start with flowchart proofs. So flowchart proofs are just another way to show a two-column proof that we've been doing. The only difference here is that we have to make arrows, so we have to show in one statement what is connecting to that. So what information am I using to be able to make that statement? Here, you usually put your statements on the inside of the box and your reasons below it. So I'm given that line GD bisects angle CBE, and that's given to me. So I'm writing my reasons below the statements. Okay, let's look here. GD bisects CBE. Okay, well here, here is angle CBE, and that line bisects it, meaning it's going to cut that angle exactly in half, so I know that these two angles are congruent. Okay, they have to be the same exact degree measure. So that means that we just said the measure of angle 3 is equal to the measure of angle 2, and that's the definition of angle bisector. Because I know that GD is bisecting that angle, it's cutting it exactly in half, making angle 3 and angle 2 have the same degree measure. And then over here, I know that just looking at my picture, and I know I need to do something with measure of angle 1, so I need to look here. Measure of angle 1 is right here. Oh, measure of angle 3 and angle 1 are vertical. So we can go ahead and say the measure of angle 3 is equal to measure of angle 1. Again, measure of angle 1 and 3, they are vertical angles, so they have to have the same degree measure. So that is going to be the definition of vertical angles. And then here, if I write this over here, so measure of angle 3 is equal to measure of angle 2, measure of angle 3 is equal to measure of angle 1. Here's my repeating part. So I can set measure of angle 2 is equal to measure of angle 1 by the transitive property. And then we are finished. All right, our last one. We are given some pieces of information. So we're given that AB equals 2x. So AB is 2x. We are given that BC is 4x. And we are given that AC is 36. We have to prove that BC is 24. Okay. So again, every proof starts out with their given, so you can either write your givens all in one big box for flowchart proofs or break it up. I'm going to go ahead and break it up. So we are given that AB is 2x, and that was given. We were given that BC is equal to 4x, and again, given, and we were given that AC is equal to 36. Okay, well, our next step, we're working with this segment, so let's go ahead and use segment addition postulate. I know my two smaller parts, so AB is plus So my small part AB plus BC needs to equal the whole thing of AC. And there we are using this segment addition postulate. And then we can go ahead and replace with what we know. So I know that AB is 2x. I know that BC is 4x, and I know that AC is 36. And how did we get there? Well, we're using substitution. Okay, and this is kind of the new part. So you should connect your different boxes. So in order to get to this statement, I used all of my givens, and I used this idea of segment addition postulate as well. And then going from here, we can go ahead and say that we have 6x is equal to 36, and we're just simplifying, combining like our like terms. And then x is 6, and we got that because we are dividing. So division, POE. So we went from this box to that one, then over here. And then I'm trying to solve for BC. Well, BC is 4x. So then that would be BC equals 4 times 6. That's substitution as well because we're plugging in 6 for x. And then BC equals 24. And we are simplifying there. So flowchart proofs can be pretty cool because it gives you a lot of freedom to be able to write your proofs. However, they can be difficult as well because you're kind of set it up to you kind of form your own format from it. So please make sure when you're doing a flowchart proof that it's nice and neat. You label everything. You don't forget your arrows. You still don't forget your reasons, stuff like that. I may only have you do a couple here and there. Flowchart proofs are not going to be very common. 2-column proofs are going to be the most common when we complete and solve for proofs.